Welcome to Calibrating Precision, your practical guide to determining statistical sample size without the academic jargon. Finding the optimal sample size is a high-stakes balancing act. Too small, and you risk a type 2 error, failing to detect real effects. Too large, and you waste time and resources for minimal gains in precision. Sample size is determined by three key pillars: confidence level, margin of error, and response distribution. Adjusting these three dials gives you the exact number of observations needed for statistically valid results. Confidence level is the probability of hitting the target. A 95% level means that if you repeated your survey 100 times, about 95 would capture the true population value. The industry standard is 95% confidence, corresponding to a z-score of 1.96. Higher confidence levels, like 99%, are reserved for critical research where risk tolerance is low. Margin of error is the size of your bullseye, defining the expected range of the true population value. A smaller margin means greater precision. Precision is expensive. Having your margin of error, for example from 5% to 2.5%, does not double your required sample size, it quadruples it. Response distribution plans for maximum variance. If you don't know the expected proportion, use 50-50. This split provides the most conservative or largest sample size estimate, ensuring your study is adequately powered. The core formula for calculating sample size assumes an infinite population. It uses the z-score for confidence, the expected proportion, and the margin of error. You only need to correct for finite populations if you know the total size, it's under 100,000, and your sample is more than 5% of that population. The finite population adjustment formula significantly shrinks the required sample size when surveying a large portion of a small, known population, like employees in a 2,000-person company. The population size myth is that a massive population requires a massive sample. In reality, once a population exceeds 100,000, its size has virtually no effect on the required sample. Precision, not population, drives cost. This benchmark matrix shows standard sample sizes based on a conservative 50% response distribution. The industry standard, 95% confidence and 5% margin of error, requires 385 observations. The calibration playbook starts with setting your confidence, usually 95%. Next, define your acceptable error, starting at 5%. Finally, adjust for population size using the 5% rule if needed to save resources.